Hello everyone. Today I have invited a guest who will deliver a lecture on NO2 emission monitoring using TROPOMI data. He will share his research. So I hope you will enjoy the video. So let's start the video.
You often find the news on air pollution. Air pollution is a significant challenge in Indian cities, with many ranking among the world's most polluted cities. Coal combustion in thermal power plants is a major source of air pollution in India. 90% of the electricity production in thermal power plants is based on a coal. Coal power is required to ensure energy security for India's development and growth. The key to efficient air quality management is thus strict compliance and monitoring of thermal power plants. Developing traditional bottom-up emission inventories and periodically updating them is the usual way to track the emissions. However, in India, the emission inventories are not regularly updated, making it difficult to continuously track the emission and assess if they violate the emission norms. The most important pollutants released from thermal power plants are sulfur dioxide, nitrogen oxides, and particulate matter. My study focused on nitrogen dioxide. Nitrogen dioxide is an important criteria pollutant affecting human health. It is one of the main contributors for formation of particulate matter 2.5 and particulate matter 10. In this case, monitoring of air pollutants is important to ensure compliance by the power companies. Here my study becomes significant. I studied the NO2 emission level around coal-based thermal power plants in Maharashtra province of India. As per the National Ambient Air Quality Standard notified by the Government of India, the threshold for the nitrogen dioxide is 40 microgram per metric cube annually. For this study, 31 plants were considered, consisting of 89 boilers. There were two objectives of this study. First one is to assess the emissions from thermal power plants. Second one is to assess effectiveness of TROPOMI observation against ground-based stations. For the objective 1, TROPOMI data was processed on the Google Earth Engine platform. TROPOMI stands for Tropospheric Monitoring Instrument. The data was aggregated for the annual intervals and then units were converted into microgram per metric cube from the molecule per square meter. The NO2 column extended for the tropospheric height of 17.3 km, that is specific for India. It was found that NO2 level around 4 thermal power plants exceeds the threshold of 40 microgram per metric cube. The NO2 emissions level were higher in regions where thermal power plants are located. These NO2 values are compared with the NO2 values which are collected from the ground-based sensors. The NO2 data of ground-based stations were interpolated over Maharashtra state using Kriging interpolation method. There are many missing values in the ground-based data. There are few sensors in Maharashtra state to monitor the NO2 emissions. It is also found that there is a temporal variation in the emissions. The nitrogen dioxide emission from year 2018 to 23 were studied. The emissions were classified into the same classes for the comparison. It is observed that emission level have significantly changed for the year 2020. The lockdown restrictions were there in 2020 resulting into lower emission. The dark blue color represent the lower emission that is observed over southern and eastern part of Maharashtra. The emission range and mean emission values also significantly differed for the year 2020. The mean emission in the year 2020 is 16.8, while that is 17.9 in the year 2019, higher than the year 2020. Further increased to 18.5 in the year 2021. I can conclude from this study that TROPOMI observation can help us to monitor NO2 emissions efficiently. This further helps in reducing risk of the health and ensuring fulfillment of the SDGs.
So if you have enjoyed the video, please do subscribe, share and like the video. Thank you everyone.